These are my experiments with different types of mirrors, and this video will tell you about one of the types of cheap mirrors which can be easily made by anyone, although we understand that this reflective film has a shorter lifespan. More expensive reflective films cover the surfaces of these mirrors, and they will live for 20 or 30 years, converting solar radiation into electricity. The construction of such solar power plants has already attracted about $40 billion in investments, and the end of my video will describe how they produce solar electricity at night just as well as on sunny days, and this fact is their big advantage over solar panels that only work during the sun. In addition, similar mirrors will produce cheap solar electricity, cheaper than electricity from thermal and nuclear power plants, but only on the conditions that we can further reduce the total cost of construction of the mirrors to this level, between $10 and $20 per square meter. Let's think about whether the cost of mirrors can be reduced to this level, and this is my experiment where we see a mirror that is several times cheaper than that level. This thin steel sheet costs $4 per square meter, and this reflective film costing 25 cents per square meter is glued to the steel sheet with this cheapest glue. But first of all, I want to remind you that the 7 previous videos described other types of my cheap mirrors based on glass rectangles, mirror steel, reflective film on expanded polystyrene, mirror balloons, reflective film on a concrete sheet on a thin steel structure, and then anodized aluminum sheets. This video will be about the 8th type of cheap mirrors, and it consists of a reflective polymer film on thin steel. I remind you that this mirror was made 3 years ago, and this is its condition after 7 months of outdoor use. Interestingly, the glue remained liquid for the first few months because its moisture had no opportunity to escape through the polymer and steel surfaces. This is the situation after an additional 3 months. And this is a mirror with an age of more than 14 months, and we can conclude that we should have a cheap method of replacing these cheap films about once a year. This is the situation after 1.5 years of outdoor use, and let's look for more durable films on steel surfaces. For example, this blogger used a more durable film which was glued to a regular satellite dish. Now we see the result of his work, and his dish focuses solar radiation here, where the radiation creates a high temperature sufficient to melt steel. We are also well aware of similar films made of vinyl or other polymers, and their lifespan can reach 10 years, but reducing their cost requires automated equipment for installing the films. Of course, if our goal is the longest lifespan, we should use special films designed for exterior mirrors. For example, this film consists of a thin metallic reflective layer between two polymer layers, and here we see that their lifespan will be several decades. We have to aim for these targets in this formula that leads us to this cost of our solar thermal energy, which is approximately 10 times cheaper than the cost of heat from natural gas. This is our target wholesale price of durable reflective films per square meter, and this is the acceptable cost of the remaining parts of the mirrors between the reflective film and the ground, and let's analyze how we can reduce their cost to $10 per square meter. We understand that the cost of these traditional systems will never go down to $10 per square meter, because their mirrors must be of high precision to focus solar radiation into this thin line. This line is a path for the circulation of thermal oil with a temperature of up to 400 degrees Celsius, which is needed to generate electricity using turbines. In addition, traditional mirrors must constantly rotate according to the movement of the sun across the sky. That is why today the manufacture and installation of these parts between the mirrors and the ground costs about $200 per square meter in Europe or the United States, although their construction in China is already about half the cost. Nevertheless, my previous videos often describe a new method of producing thermal energy, when the mirrors are absolutely motionless, but we have to move these receivers, where the focused solar radiation hits the thermal oil which circulates through this pipe. It is obvious that the system of movement of the small receivers is radically cheaper than the system of movement of huge mirrors, but the motionless mirrors produce about 3 times less thermal energy, which was taken into account here. In addition, our mirrors have the right to not be precise, and my previous videos often showed my experiments where imprecise mirrors create a temperature of 300 or 400 degrees Celsius. It is interesting that these cheap mirrors with short lifespan may also make economic sense, but only on the condition that we have a cheap way to replace the films and the total cost of the replacements reaches this level per square meter. Let me remind you how these solar power plants produce electricity, and I already said that during solar hours these mirrors focus solar radiation, which heats the thermal oil here. After that, the hot oil heats molten salt inside these tanks and returns to the mirrors to be heated again. That is why we have thousands of tons of molten salt with a temperature of almost 400 degrees Celsius, and this heat will produce steam for turbines both day and night. But such a radical reduction in the cost of solar heat recommends replacing this expensive molten sodium and potassium nitrates with heating large masses of concrete, sand, soil, or other cheap materials. They can store thermal energy for several days to several months, and these solutions were described in these my two videos.